Hi everyone, welcome to Last Minute Maths. In this video we're going to be looking through the June 2020 EDEXCEL Maths Paper 3, higher tier, and it's a calculator paper. Just in case you're wondering, June 2020, the exams were cancelled and the paper was actually used in November. So on various websites you're going to see it marked as November 2020 instead. So just in case there's any confusion. All right, so we're going to jump into it. And remember, it is a calculator paper, so in some areas, reach for the machine to work the answers out. Okay, question number 1, all about indices. And in this, it's fairly simple. Remember, when you are multiplying powers, numbers with powers on them, you are going to add the powers, all right? So in this case, n to the power 3 times n to the power 5, add the powers, 3 plus 5, and your answer is n to the power 8. All right. And next one, simplify. So you've got c cubed times d to the power 4 over c squared times d. And when we're dividing, remember you subtract the powers. All right. So in this case, we treat each of them separately. So the c's there and the d's separately. Sorry, I've just butchered that particular question. Right, so what we have is c to the power 3 minus 2. All right, I'm going to erase that again so you can see the original. And times d to the power 4 minus 1. Remember the d on the bottom is a power 1, all right? Just in case you've forgotten the basic rules on that. And so the thing comes out to be c times d to the power 3. All right. Do watch out for my separate video. I've got another video on there for laws of indices. Oops. So if you need to revise that, do take a look through that video there. Okay. Next question. Part C. Solve 5x over 2 greater than 7. Treat it like a normal equation, as if though there's an equal sign, all right? And solve it exactly the same way, but just leave the greater than sign where it is. So 5x times 5x is greater than 7 times 2, so that's 14. So we move the 2 across to that side, multiply by it. And so x is greater than 14 over 5, so divide by the 5, okay, that way. And you can leave the answer both ways, right? It doesn't make a difference where you put it as a improper fraction, 14 over 5, or x is greater than 2.8. Calculator paper, so you're more likely to put it in the calculator if you wish. Both answers are marked as correct, so no big deal there. Right, number 2, you've got a distance travel thing, distance traveled and speed time calculation. It says Andy cycles distance 30 kilometers, average speed of 24 kilometers an hour, and then a run of 12 kilometers at an average speed of 8 kilometers per hour. Okay, so you've got part A and you've got part B in this entire journey, if you like, if you want to call it that. So what do? We want the total time, is what the question is asking for. All right, so total time in hours and minutes. Remember the triangle thing that you're all used to seeing, okay? Speed equals distance over time. Distance equals speed times time, etc. I'm sure you're familiar with that. So from that, we're going to use that time equals distance divided by speed, all right? So for part A, the time equals 30 kilometers traveled over 24 kilometers per hour, all right? That gives us 1.25 hours. We're going to leave it in decimals for now and then tidy it up at the end. Part B, the run of 12 kilometers. So that's 12 kilometers divided by 8 kilometers per hour, and that gives 1.5 hours. So the total time, adding those two, 2.75 hours, all right? So 2 hours, obviously we're okay with that. The 0.75 hours needs to be converted into minutes. So remember, 60 minutes in an hour, 0.75 times 60 equals 45 minutes. All right. So the total time, 2 hours and 45 minutes. Okay, number 3. Fairly simple, this one. It's rounded to one decimal place, it says, all right, a number m, and the result is 9.4. Okay, so 4 is the rounded number. You then want to consider whatever comes next. That's the bit that is relevant to the question. So the error interval, it could have been as high as 9.45, okay, and as low as 9.35. So in other words, if it's rounded to one decimal place, so that's that number there, it's the next one would go, sort of like 0.5 up or 0.5 down. Okay, so hopefully that's self-explanatory. As always, if there's any questions, then yeah, leave it in the comments and I'll happily respond to that. The answer therefore is m is less than, they've made your life easier by putting the signs in there already, less than 9.45 and greater than or equal to 9.35. So the 35 can be rounded up, so that's included, but obviously has to be less than 9.45. 45 would normally be rounded up to 9.5. Okay, so that's why that's a less than sign. Right, number 4. Maisie knows that she needs 3 kilograms of grass seed to make a rectangular lawn, 5 meters by 9 meters. So that effectively is 45 square meters from 3 kilograms. All right. And it tells us that the seed is sold in 2 kilogram boxes. And ultimately, she wants to make a rectangular lawn of 10 meters by 14 meters. So that's 140 square meters. All right. And 5 boxes of seed. When you do these slightly wordy questions, please do, as I've shown you, underline the key bits of data. That really does help, especially if you're rushing, so you don't lose sight of important parts of the question. The question is that, has she got enough to make a lawn 10 by 14? And so what we're going to do first is work out each kilogram of seed will cover, as we were told earlier, 45 square meters for 3 kilograms. So 45 divided by 3, it's 15 square meters per kilogram. All right. Applying that to the box of seeds, which is 2 kilograms, each box covers 2 times 15, which you just worked out, and that equals 30 square meters. And now we're going to see that for the 140 square meters that she actually wants to cover, how many boxes does she need? All right. So 140 divided by 30, 4.6, you might want to call that 4.67. Yeah. So 4 2/3 boxes. So she has 5. So the answer is yes, she has enough boxes to cover the 140 square meters that she wants. Then it says Macy opens the 5 boxes of grass seed and she finds that one of the boxes has only 1 kilogram in it. All right. So effectively she's got 9 kilograms, right, instead of 10. Okay. So what effectively that does is that the 9 kilograms are the same as 4.5 boxes. Right? You can answer this question whichever way you like. In other words, you can talk in terms of boxes, or you can say, well, she originally needed, 10 kilograms, and she's now only got 9, right? Something like that. So I've left it in terms of boxes. So she needs 4 2/3 boxes, 4.67, but she now has effectively only 4.5 boxes, so not enough. All right. And the answer, I suppose you'd probably start with a yes. All right, bear that in mind. Okay, hopefully that's clear. Right, Amanda has 2 fair-sided spinners, and she spins each spinner once, so one after another. All right, so the probability tree works out like this. The spinners have 1, 2, and 3 on them, so they're identical and they're fair, all right? And so the tree diagram says for spinner A, the probability of landing on a 2, well, there's a 2 and there's 2 other numbers, so it's 1/3, all right? You can see there. And does not land on a 2, so that's a 1 or a 3, so the 2 options, 2/3. The second spinner, spinner B, since it's identical, it has exactly the same probabilities. The probabilities do not change, all right? So landing on 2, again, 1/3, does not land on 2, 2/3, and the same thing is repeated, all right? 1/3 and 2/3 again. Okay, so this time we want to work out the probability that spinner A lands on 2, and this is the important bit, spinner B does not land on 2, okay? Whenever you have an and in probabilities, it means you multiply, okay? You multiply the probabilities of the different events. So the probability of A landing on 2 is 1/3, okay? And then the probability of B does not land on 2 is 2/3, all right? So the two events to happen, so A happening and B happening, as the results say, you have to multiply, all right? So 1/3 times 2/3 gives you 2/9, and that's your answer. All right, question 6, all right? Now, again, just before I dive into this, simultaneous equations, if there's any confusion on this, there is, again, a separate video. I've got a full rundown of simultaneous equations on my channel, so do take a look at that if you want to explore simultaneous equations in more detail. All right. All I'm going to say on this one is simultaneous equations, when they are linear, so there are no x squareds or y squareds in it, then these are effectively straight lines, all right? And the solution that they're looking for is where the lines intersect, okay? So the bit that we're after is that, the coordinates of that point there, okay? So the graph shows us where they intersect is actually at x equals -2 and y equals 4, all right? Very simply put. And remember, these are equations of straight lines. Just as a point of revision, I'm going to add this in, take a few extra seconds of your time. The 5x minus 9y equals -46 can be rewritten in the following form, right? 5x plus 46, and put the 9y on the other side. And therefore 5x over 9, so 5/9 of x plus 46 over 9 equals y. And that has effectively the same form as mx plus c. So that's how it becomes a straight line. All right. Right. Moving on from there. Second part of this question. Quadratic graph. You can see x squared minus 4x plus 2. And all it wants is estimates for the solutions, right, for the quadratic equation equaling 0. So all you're looking for is where does the graph equal 0? That means where does it cut the x-axis? All right. So the points as circled on the graph there, the actual values, if you read it off there, all right, is 0.6, x equals 0.6, and the second one is x equals 0.4. And remember, in a real exam, they will give you a slight latitude. It is an estimate. So if you were to say, I don't know, 0.7 or 0.5 or something like that, they still allow it. But try to be as accurate as you can. All right. All right. Question 7. There is a total of 45 boys and girls in a choir, right? And the mean age of the 18 boys is 16.2, and the mean age of the 27 girls is 16.7, all right, in terms of years. And it says calculate the mean age of all of them combined, all right? Like that. Whenever you've got separate means like this, all right, the combined mean, you always have to calculate the individual totals first for each group and then combine them. I'll show you how. So mean of all of them combined is the total years for all children, in this particular question that is, for all children, and then divide by the total number of children, okay? So for the boys, the total number of years, you use the data they've given you. So 18 boys, average age 16.2, multiply those and it gives you 291.6 years. For the girls, 27 times 16.7 equals 450.9 years, all right? So the total number of years for all the children, 742.5, and you then divide that by 45 children in the choir, and the mean comes out to be 16.5, all right? So again, for these types of questions, always go back to the totals, add up all the totals, and then work out the mean for the combined data. All right, so question number 8, probabilities, all right? Some counters in a bag, and there are different colors, blue, green, red, yellow, etc. And the table gives you the probabilities. They've already given you the probability for the blue and the green, right? 0.32 and 0.2 respectively. One thing you must note is that in this particular scenario, when you have like a choice of however many things, the probability of all the different outcomes, all the different choices, okay, must add up to 1. So whatever the missing ones are for the red and the yellow, right, added to the blue and the green must equal 1. Fundamental. So they then give you extra data. The probability that a counter taken at random from the bag will be red, for example, is 5 times that of the probability it will be yellow, all right? So red is 5 times more likely than yellow, okay? And then they tell you about 300 counters. So we're going to come back to that in a bit. The question actually wants you to work out how many yellow counters are in the bag, okay? Before we can do that, we have to work out the probabilities, all right? So since yellow in this one is a smaller one and red is 5 times the yellow one, we're going to let the probability of picking a yellow be x, and the probability, therefore, of picking a red must be 5 times that, 5x, all right? Together, that means it's 6x, all right? And we know that the two probabilities we already have, blue and green, together make 0.52. So the remaining probability must be 0.48, all right? So 6x represents 0.48, and therefore x equals 0.08. So 0.48 divided by 6, all right? So therefore, the yellow counters must be the probability of yellow, which we've just worked out, all right? So remember, this is the one for yellow. Okay, so 0.08 times the total number of counters with 300, and that means that there are 24 yellow counters in the bag, all right? Number 9, the diagram shows a prism, all right? And the statement that it's exactly one line of symmetry means that you can slice it straight down the middle, the way I've shown it there, all right? And there's a reason for that, because we need to start working out areas. So it says it wants the volume of the prism, and remember in this question they're specifying 3 significant figures. So in normal calculations like this, any prism, you calculate the volume by multiplying the cross-sectional area times the length of the prism, all right? The assumption there is that the cross-section remains constant all the way through, okay, which is standard for GCSE, So the first thing we have to do, we know the length already, all right? The length is 20, all right? So we need to work out the cross-sectional area. And as you can see, the cross-sectional area, there are two bits to it. There's a triangle at the top, and there's a rectangle underneath it. So we're going to treat those separately. The rectangle, R, plus the triangle, gives you the total cross-sectional area. The rectangle is straightforward, 12 times 10. All right, if you look at the question there, 12 times 10 for the rectangular face. So that's your 120. The triangle, this is a bit that needs a bit more clarification. Where they said it has one line of symmetry, that means that the triangle can be sliced down the middle and you can work out the height of the triangle, because for the area, remember, we need half times base times height. And in this case, we don't know the height to begin with. So we need to use a bit of trigonometry. They've given us the angle, 40. We know the base of the triangle, right, is 10. Okay, so using SOHCAHTOA and noting that for the half triangle, the base is 5, right, for the right angle slice of the triangle. From SOHCAHTOA, right, the H represents the opposite, and the 5, the base, represents the adjacent. All right. So from that, we know that we're going to use the TOA bit. All right. Tangent of an angle is the opposite over the adjacent. Opposite over adjacent. So therefore, we can write tan 40 equals H divided by 5. All right. Rearranging that, taking the 5 over there. 5 times tan 40 gives us H, which is 4.195. All right. So feeding that back into our calculation, we've got the area for the triangle, the full triangle, half times the base, which is 10, times the height, which is 4.195, that we just calculated. So 20.975 in total. So the cross-sectional area in total is 140.975 square centimeters. And the volume, therefore, is cross-sectional area times length. So 140.975 times 20. And that gives us 2,819.5. Remember, the question wanted 3 significant figures. All right. So we're only going to take the 281 and then look at the 9. So it rounds up to 2820. All right, that's your answer there. All right. Question number 10. Right, now I've just messed with this question just a little to demonstrate. The bit that you want is this bit. Okay. I'm going to go through this and just show something as an alternative later, which those of you who don't need to know it, just skip forward to the next question. So a person's heart beats approximately 10 to the 5 times a day. All right. So that's like 100,000 times. A person lives for approximately 81 years. All right. Healthy people. And they want an estimate for the number of times a person's heart beats in their lifetime. All right. And they want it to 2 significant figures in standard form. Okay. So all you're doing is taking the 81 years times 365 days times 10 to the power 5 beats per day. So effectively you're converting all of that into total number of heartbeats in a lifetime. Okay. And you get 29,565 times 10 to the power 5. Big old number. And what we're going to do then is effectively move the decimal 1, 2, 3, 4. Because remember, the base number has to be between 1 and less than 10. All right. So less than. So in the range 1 to 10. Okay. So we're taking or dividing that by powers of 10. So that's 4 of them. That's why we put that with the powers of 10. So 10 to the power 5 goes to 10 to the power 9. and this number on this side gets smaller, 2.9565. So to two significant figures, we just want the first two, 2.9, and it's followed by a 5. So we're going to turn that into 3.0. Because they want two significant figures, you must have the 0 there, all right? And I should actually rewrite the answer. I was doing a bit of a shortcut earlier. So you must have the 3.0 in the answer, okay, 2SF. Right. Anybody who's happy with that can skip forward. And I just want to show something for paper 1. If this were a paper 1 question, exactly the same thing. Paper 1 method. Remember, if you were doing this for paper 1 and they asked you for an estimate without a calculator, then you would convert all of them, take one significant figure. So 81 becomes 80, 365 becomes 400. Multiplying that, powers of 10 coming out, and you come to a very similar answer, but not quite. But I just wanted to demonstrate as a point of revision. The same type of question can come up in paper 1, and in that sense, you take only the sort of one significant figure. And if you rearrange that to one significant figure, that actually gives you effectively the same answer. All right. So let me just put that in. All right. As I said, that's just a point of curiosity. Feel free to move on and skip forward there. All right, and the next bit is 2 times 10 to the 12 red blood cells have a mass of 90 grams. Okay. The average mass of one red blood cell is therefore just simply the total mass divided by the number. All right. Not much explanation needed here. Divide the 90 by the 2 times 10 to the power 12 calculator, and it gives you 4.5 times 10 to the minus 11. All right. Not too difficult. Right, this question is going to take a little bit more discussion. I'm going to try and get through this as quickly as I can. All right, let me squeeze this thing down. So you've got a triangle P, all right, initially, and you can see it there. And it says it's rotated 180 degrees about the origin, 0, 0, to give triangle Q. So effectively what you're doing is drawing a line to the origin, okay, and rotating the whole thing like that, 180 degrees, all right? And so along there, if you draw that, it's a straight line, 180 degrees is a straight line. And you can see how that's done, where the whole thing rotates down. In a rotation, the orientation, the way the shape looks, will change, okay? It's not going to be the right way up and so on and so forth. Then it says the triangle Q that you've got initially is then translated, all right, by this column vector 5 minus 2. Remember, column vectors, translation vectors are x and y in that order. So in this case, 5 means you go across 5, and then minus 2 means you're going down 2, all right? So look at what happens. Across, take that point there, and then 2 down. So that's 5, and that's minus 2, all right? And you do that with the other 2 points, and you get triangle R. Then it says, describe fully, all right? Fully, a single transformation that goes from P to R, all right? Looking at P and R, we can see that the shapes are not the same way up, and indeed it's not a reflection, okay, up, down, etc. So this must again be a rotation, all right? So how do we find that? The way to find the center of a rotation and how far it's gone is that you have to connect the points, let's say corresponding points. So I'm going to take the sharp end of this triangle, the wedge there, and this one here. You connect them with a straight line. Okay, so if you're doing this in an exam, sharp pencil, ruler, and you connect those 2 corners. And then you pick another corresponding pair of corners. So I've taken the thick end of the wedge, sorry, and I've connected those two. Where the lines intersect, there, that is your center of rotation. Okay, and I'm not sure if I've written 90 or 180, but that again is 180 degrees rotation. Yep. So effectively you've got a rotation, 180 degrees, and about the center of rotation that we're going to find from those two lines intersecting. And as you can see, it's 2.5 and -1. Okay, that's what we put in the answer there. Again, any confusion, please leave it in the comments and I will happily get back to you with further explanation if you need it. The next part of this question asks for a point. There is a point in that rotation, that final rotation, that is invariant. So meaning doesn't change. So it's not affected by the rotation. Okay. Now, in any rotation, it's the actual center of rotation that is invariant. Everything else around it is going to rotate around, spin, but the actual point of rotation does not change. It will not move under the rotation. So the answer to the question is the same one. It's the center of rotation. Okay, and that's 2.5 minus 1 again. All right, so next question, 12. It says express those two algebraic fractions as a single fraction in its simplest form. So same as when you do any form of fractions and you're adding or subtracting, whatever the case may be, you have to find the common denominator. All right, so that's simplest version is times the two denominators, but you then have to make sure that you've converted the top as well. So in order to get this one to be BD, we multiply by D and the top also multiplied by D. And this one here, in order to make it BD, we multiply top and bottom by B. All right, so that becomes AD. Sorry, my pen's playing up a little. All right, let's do that. So plus CB, etc. So using that method of fractions, what we effectively have is that we're going to multiply this one, the first one, top and bottom by the other denominator. So like cross multiplying, x minus 4, so there. And the second fraction, we're going to be multiplying it by the x plus 2 denominator of the first fraction. Okay, hopefully that makes sense. Just refer to this thing here. All right. So underneath it, we've got the common denominator, x plus 2 times x minus 4. And on the top, we have x times x minus 4 plus 2x times x plus 2. All right. So expanding those brackets out, we've got x squared minus 4x plus 2x squared plus 4x. All right. All divided by that common denominator, x plus 2 times x minus 4. Tidy everything up, you've got that cancelling with that. X squared plus 2x squared, 3x squared, and that is actually your answer. All right, not overly complicated, but please remember the cross multiplication method for fractions. All right, and the next one is, again, not a difficult question, but plenty of opportunity to misplace a sign or get something in the wrong order, etc. So do it methodically. Multiplying out 3 sets of brackets, you want to multiply the first 2, right? It doesn't matter what order you do them in, but just do 2 of them first, and then later on multiply by the third one, whichever ones you pick. I'll just go with the standard, x minus 3 times 2x plus 3, all right? And remember, you're going to times all the elements, all right? And I'll leave it to you to verify that the middle term is minus 3x. because that's effectively x times 3, 3x, minus 3 times 2x, which is minus 6x. All right. So 3x minus 6x gives you minus 3x. So hopefully that's clear. You then multiply that quadratic, which is a result of the first two brackets being multiplied, by the third one. Okay. And again, there is no shortcut. Just methodically multiply everything out. And you're going to get 6 terms. Right. So just to start you off, 2x squared times 4x is 8x cubed. 2x squared times 5, 10x squared, minus 3x times 4x, minus 12x squared, minus 3x times 5, minus 15x, and then minus 9 times 4x, minus 36, and finally, minus 9 times 45, minus 45. Tidy that all up, and hey presto, there's your answer. Okay, so 8x cubed minus 2x squared minus 51x minus 45. All right. Okay, question 13. These are inequalities, all right, drawn as lines, and they want the region. Okay, in these questions, really important to make sure you've got the signs in the right directions. Okay, and you need to plot or at least draw these lines. All right. The first one, you've got x is greater than or equal to 0. All right. So x equals a value of any kind is going to be a vertical line. So I'm going to put that there. That's a vertical line. In fact, those two are both vertical lines. All right. So that one is through the origin. X is greater than or equal to 0 through the origin. And you want to be greater than or equal to. So we're on the right-hand side. Okay. We want to be greater than, like that, which I've already drawn in the arrows there. The next one is x is less than or equal to 2. So there's 2. And we want to be less than. So as I've already drawn there, less than. So to the left of that line and to the right of the line through 0. Okay, so we're between those two straight vertical lines. The next line is y is less than or equal to x plus 3. Okay, this is where you need to know your y equals mx plus c stuff. And I'm about to release a video on that, so do watch out for that, explaining all the gradients and how to sketch these lines quickly. So we know that the line goes through 3 on the y-axis. That's a y-intercept. So there. And the gradient x is 1. Right? When there's no coefficient, that effectively is the same as a line that is 1 times x plus 3. So the gradient is 1. All right, so that's the gradient there. Okay, so 1 across, 1 up, and so on. Okay, so that line is self-explanatory. The next line, and I've shown that below, I think. Before I move on, the y is less than or equal to x plus 3 means we have to be below that line. All right, and here, below the graph, I've taken the final condition, inequality, and I've rearranged it. So put the 2x on the other side, so it becomes a minus 2x plus 6. That's 3y. And then divide everything by 3. So this is giving you exactly the same format as a straight line equation, all right, just with a different sign. Remember that whatever's in front of the x is your gradient or slope, and the c is your y-intercept. Okay, so we want to start with that point there, so 2, and I've marked it on there, all right? So y equals 2 at that point, and then the gradient, the way to interpret it, if you're not too sure about gradients, that thing there, minus 2 over 3. The top number is the y, okay? And the bottom number is the x. How to interpret it, if you're not sure, is effectively it's minus 2 means the way to like put it into plain English is down 2, all right? But usually you start with the x, so go 3 across, down 2, right? So minus 2 over 3, read it to yourself in the following way. It's 3 across, down 2, because it's negative. If that had been positive, then you'd go up 2, all right? So if you're not sure how to draw that, just use that method, okay? The bottom number, the denominator, that's across, whichever way. So in this case, it's positive. So to the right, so 3 right, down 2, okay? So from there, we've gone, for example, 3 across and down 2. That's your next point. Keep repeating that process and you get a straight line. All right. Hopefully that makes a little sense to you in these particular types of questions. So the region, we want to be above that line there. Okay. We want to be between the two vertical lines and below the earlier thin line there. So effectively the range, so the region that you want is there. Okay, and that's what you would shade in the actual exam. Hopefully that's made sense. Again, any confusion, questions, please do leave it in the comments. All right, second part of the question. They've given you all these inequalities. You don't need to plot anything, but you do need to note the signs. All of those signs are either greater than or less than or equal to. That's the important part of this question. It says, Jeffrey says of the point with coordinates 2, 4, which is effectively there, all right? 2, 4 does not satisfy all the inequalities because it does not lie in the shaded region. It's effectively on the edge, all right? So it's on the line. Okay. Is Jeffrey correct? Must give a reason for your answer. Jeffrey is not correct, all right? No, because the greater than or equal to or less than or equal to, all right, signs or conditions are shown by solid lines. And so points on the lines do satisfy the inequalities. So he's wrong, okay? In those situations, anything on the edge of the region is also valid. All right. Number 14, okay? They've given you a circle theorem question. There's a tangent there, okay? And inside it, what you have is a cyclic quadrilateral. Means all four corners, quadrilateral, whoops, that should be an I, lateral. All four corners are on the circumferences of the circle, circumference of the circle. So there, 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 and there, all right? And they want you to find what I've labeled as X, angle ABD. So in this case, we're going to start off with using the cyclic quadrilateral. If we know that this angle here is 100, then the opposite angle must be 80, right? Because cyclic quadrilaterals have this property where opposite angles add up to 180, all right? Okay, second thing we do. If we know that this is 40 and that's 80, then add them up, 120, and angles in a triangle must add up to 180. So if that's 120, this one must be 60, all right? So using that property, angle BFD, all right, equals 180 minus the sum of the other two angles, so therefore equals 60. And stating that angles in a triangle add up to 180 must show you reasoning, all right? And finally, the relationship, and this is the bit that I need to draw. Okay, if you have like that, this angle will always be equal to that angle. That's called the alternate segment, which I've stated in the solution. And okay, alternate segment theorem. And so therefore, if you were to turn the paper over and just look at it in a different orientation, you'd realize that the angle X over here actually equals angle BFD over here, which we just found, because of the alternate segment. All right, and so those two angles are the same, therefore angle ABD is 60, and your answer, therefore, angle ABD equals 60. All right. Okay. Again, if that confuses you a little, maybe a revision on circle theorems, and that should be fairly clear. Number 15, recurring decimals, converting to fractions. Okay. The trick always is multiply the decimal you have. Let that be X. So X equals the decimal that you're working with. Multiply it so that you can have the decimal places line up with the same digits. All right. So you've got 333, 333, etc. All right. So when you take one away from the other, you get rid of all decimals. You're left with just an integer number. So for example, if I say 100x minus 10x, 90x, fine. And that is effectively 73.333 minus 7.333, and that gives us 66.000, etc. That is what we're after. We want a way of getting it into an integer number. All right. So 90x equals 66. Therefore, x, which is the original recurring decimal, is 66 over 90. Divide top and bottom by 6, and you end up with 11/15. So showing what they asked you to prove. All right. And then question 16. Speed time graph for a car. And they want you to work out an estimate for the distance the car traveled. Always remember, in a speed time graph, okay, the area under graph, under the graph, equals distance. All right, that's the important bit. Must remember that. Okay, so we want for this an estimate, right, up to 30 seconds. So what we're going to do as an estimate, we're just going to use a triangle. Join 0 up and use the triangle as an approximation. Okay, so the area for that triangle, you can see the height there is 8.8 because one of those squares, 5 little squares, right? So 1, 2, 3, 4, 5 represents 2 meters per second, right? Or 2 meters if you like. And so each of those is 0.4, right? And so the height there is 8.8. Please do not write 8.2 just because it's 2 little squares up. Make sure you look at the scale, all right? The scale is very important. Okay, so half times the base is 30, times the height, 8.8, and in your calculators, 132 meters, and that's your answer. Nice and simple. They then go on to ask, in your answer to part A, right, is it an underestimate or an overestimate of the actual distance, all right? So look what's happening here. There's a little gap, yeah, between the actual curve and the triangle, the edge of the triangle that we've used to calculate the distance. So therefore, we've actually taken a slightly smaller area than in the actual graph itself. All right, so it's an underestimate, and the explanation is the side of the triangle is lower than the curve, so actual area is larger, or the real area is larger. All right. Okay. That's a bit of a misprint somewhere. This should be, oh, okay, this is the second part of that thing there. All right, use the same graph, right? Julian used the same graph to answer this question. Work out an estimate for the acceleration, okay, of the car at time 60 seconds. So it's at a specific time, all right? The acceleration on a speed time graph is given by the gradient. All right, so you need to work out the gradient at 60 seconds. What Julian has done in his working is just taken the speed at 60 and divided by 60. So that calculation there. The problem with that is that it does not actually give the gradient at 60 seconds. It gives the overall average. So acceleration is given by the gradient, fine, at any point. His method gives the average acceleration over the first 60 seconds. Therefore, he's actually not worked out the acceleration at a given point. I'm going to go back to the graph and just show you how you would do it in reality. At 60, you would probably work out some sort of an estimate, like a tangent there, and then use that as a triangle, just roughly showing you, and work out the gradient. All right, so the y difference and the x difference, and work out the gradient. That would be the acceleration at 60, not what he's done. All right, hopefully that makes sense. Right, question number 17. Histograms. All right, remember, in a histogram, okay, the frequency is given by the area, not the height. Area equals frequency, and the height, as we can see, is given by or rather the height gives the frequency density. All right, so the frequency itself is area. Now, in this histogram, as with all histograms, you've got ranges. All right, so from there to there. Oops, hang on, sorry, should get rid of that middle bit. And then there to there, there to there, and there. All right, so you've got little classes of data. All right, they're asking for a mean distance. In any grouped data, okay, in order to work out the mean of the data, you've got to use the frequency times midpoint, right? Frequency times midpoint, okay? And then total up everything, divide by the total number that you have. So what we have to do now is work out the frequency for each group, all right? So remember, the area equals frequency, all right? So the area is going to be just height times the width, okay? So area 1, area 2, 3, and area 4, okay? So area 1, the width is 7.2 minus 6.4, so that is 0.8, right? So times 10, which is the height here, okay? That gives us 8. Without boring you to tears, just to say, using the same method, the height in each case, you have to just read off the table, and that one there, all right? So area 2 given by the width, 0.4 times 50, all right, 20. Area 3, 0.4 times 100, 40. And area 4 is 0.2. Remember, this one is just 0.2 times 60, 12. All right. So that just verifies. It said at the beginning of the question 80, so that's fine. So we know that's okay. We then have to work out the midpoint of each of those groups. All right. So this first one, the midpoint is there. Second one, midpoint is there. Third one, midpoint. So this one here is perhaps a little more tricky. 8.1, okay? And so all we're doing is multiplying the midpoint by the frequency, all right? And then adding up all the totals. So you can see it on screen. I'm going to read out all the decimals for you. Just keep multiplying each one, and you got 54.4, 148, 312, and 97.2, etc. Add it all up. So the total, that effectively is a total distance jumped by all the competitors. And it's an estimate because we're using midpoints. It is not accurate, it's an estimate, as they've said in the question. So that total distance divided by the number of competitors will give us the average distance jumped by each competitor. So that's 7.645. The question hasn't stated one decimal place, three significant figures, two, whatever, etc. So we just write down all the numbers here to be safe. All right, 7.645. Okay, quickly moving on to the next question, 18. What we have here is 3D Pythagoras. Okay, because we're going from the back top corner to the front bottom corner here, H, right, through the center of the cube. Okay, assuming what I've put in is the, and it's a cube, remember, all the sides are equal. So I've let it be X, okay? You can choose any letter you like, makes no difference. And they've said that AH is 11.3 correct to the nearest millimeter, all right? So effectively, the 3 is where it's been rounded, okay? So like in the previous question, you go to the next decimal place, and it could have been as high as, well, just below 3.5, and down half, so 25. So if you think of that as being 30, then it could have been up to 35 and down to 25. Okay, that's the way to think about it. Now they want the lower bound. Okay, so we're not interested in the 11.35. We want what could have been, I suppose, the lowest possible value. And we're going to use the 11.25 here. Okay, so three-dimensional Pythagoras, you just sort of take the square of all the sides involved, of all three dimensions. So AH squared equals x squared plus x squared plus x squared, because there's three different sides to it. So I'm going to treat it like that. That one, and that one. Okay, so effectively that's 11.25 squared equals 3 times x squared, adding those up, all right? And it's a calculator job, so put that in your calculator, and you get x squared equals 42.1875, and x equals square root of that, and that's 6.495190528, all right? Again, they haven't given you any rounding instructions, 1 or 2 decimal places or significant figures, etc. So safe bet just to put all the numbers in. You could, if you wanted, make your own judgment, but take a reasonable number, all right? And you could have put in 6.495, but it's probably safer just to put them all in there. All right, this next question is perhaps a little lengthier. You've got 2 hexagons, one scaled up from the other, all right? Regular hexagon, that's important. Regular means all sides are equal. So, and it says that with sides of length x, all sides equal. All right, and that hexagon, that small white one, is then enlarged by a factor f, center f, right? And by a scale factor p to give the bigger one, all right? And it's saying show that the area of the shaded region, so this bit here, in the diagram is given by a particular expression that looks nastier than it actually is. The important thing to note is that this area is the difference in area between the two shapes. The two shapes, right? Okay, so first thing we're going to do, we know that a regular hexagon is made up of equilateral triangles, all right? And that's what we have in the small one here. And effectively, you're looking at these triangles here, all right? And they have side x. Property of equilateral triangles is that the angles are all 60, okay? Very similar to the question that we did with the prism earlier on in the paper. We, again, in order to work out the area, need the height, all right? And we're going to use SOHCAHTOA again. This time, different to the previous question, all right? We want the opposite, and we could use, I don't know, either the hypotenuse or the adjacent. I've chosen to use the hypotenuse, so I know I want the relationship between the opposite and the hypotenuse, and that's sine. So sine 60 equals h over x, all right? Opposite over the hypotenuse, okay? And so rearranging that, h equals x sine 60. Put that in your calculator. H equals root 3 over 2 times x, all right? That value there. And so the area will equal the base times height times a half. So half times base times height, etc. So we know the base is all the way across there is x, same as all the other sides. And the height, root 3 over 2 times x times 2. And we get a value for one equilateral triangle in the small hexagon, root 3 over 4 times x squared, all right? So the small hexagon in total, because there are 6 of those equilateral triangles, that's going to give us 3 times root 3 over 2. So 6 divided by 4, 3 over 2, okay? So that's the area of the small hexagon. Now, I'm going to put this in a little box here, okay? A bit of revision from earlier things with scale factors. If the scale factor of a length is p, in other words, if you're enlarging the lengths by a certain factor p, then the area of a shape will be enlarged by a factor that's p squared, all right? That's the thing that you need to remember for this question, all right? So you have to multiply the area by the scale factor squared, all right? So that is scale factor squared, in order to get the larger area. So the large hexagon area, okay, is given by the area of the small hexagon times the area scale factor, which is p squared, all right? So effectively, you can see it here, there. So therefore, the shaded area is the area of the large hexagon minus the area of the small one, okay? I'm sorry I've squashed it in at the bottom of the page, but I wanted to just get everything clearly laid out there. So if you need to enlarge this, please take a moment to look at it. So the large one minus the small one, they've got exactly the same components except for that p squared. So we can factorize out the 3 root 3 over 2 times x squared, and you're left with a p squared there and effectively a 1 here. So that's what they showed in the question, p squared minus 1. And on the outside, you've got the 3 root 3 over 2 x squared, all right? And it doesn't matter whether the x squared is after the brackets or before the brackets. Hopefully that's made sense. And any questions, leave it in the comments. Right, number 20. This is a little bit of a trick question. Notice there's only 1 mark, all right? All of these numbers are multiples of 98, okay? So if they're all multiples of 98, and in fact, the only number that's in there is 98 times 98 a lot of times. So therefore, the largest one must be the common multiple, okay, of all the others. So all it is 98 to the power 91, all right? Probably not much explanation needed for that one. And I think this might be the final question. Is that the final one? There it is. All right, so almost done. And in this, they want the ratio of C to D. All right, so they've got a statement, 5C plus D equals C plus 4D. And they want you to rearrange that to get the ratio of C to D. So treat it like a normal equation. Collect all your C's and D's on opposite sides. So 5C minus the C from this side equals 4C, and the 4D minus the D from there, 3D. All right. So if 4 C's are the same as 3 D's, then it implies that the C is smaller than the D. If you're not sure which way round, the most common mistake is getting the numbers the wrong way round. Okay, so if you need more C's to equal fewer D's, all right, then C must be smaller. Okay, so put the smaller number. So I'm going to just rewrite the method here. Something very simple and something you can do without even thinking is move that number to the C and that number to the D. So that becomes 3 and that becomes 4. All right, that is the simplest way to do it. Okay, if you want a quick hit, that's the one. So C to D, the ratio is 3 to 4. All right. Next step is part of the question is just a little bit more complex. It's given you what looks like a nasty quadratic with something with a 7xy in the middle, etc., etc. All right, but also note that x and y are both positive, okay, and they want the ratio x to y. Okay, what we're going to do, and you can do this either step, doesn't matter which way you do it. You can either move everything to one side first, so that minus 7xy minus 20y squared equals 0. Or, as I've done, I've divided everything by y squared first. Okay, oh, that's a bit messy. Divide by y squared first, and then I've decided to move it around. So it does make a difference which way you do it. What you need to end up with is this expression here. Okay, and effectively you've got 6x squared over y squared minus 7x over y minus 20 equals 0. If we think of it as being 6 times x over y all squared minus 7 times x over y minus 20 equals 0, we can see that it looks like a quadratic. All right. So if we use a little transformation, let any letter you want to pick, a equals x over y, for example. So let a equal the term x divided by y. Replace that. So that becomes 6 times a squared minus 7a minus 20. That's a normal looking quadratic. Something you're more used to seeing. All right. And then factorize that. And again, I've got a full video on factorizing more difficult quadratics or more complex quadratics that's on the channel, so feel free to take advantage of that if you want. And it's called the decomposition method, in case you want to look that up. Quadratics video. Okay, right, so when you break this thing down, it comes to 2a minus 5 times 3a plus 4, okay, equals 0. That gives us two solutions. One is a equals 5 over 2, or the other one is a equals minus 4 over 3. Now we can't have negatives because of what the question said right at the beginning. Remember, x and y are both positive, so you can't have a negative number in there, all right? So effectively, a, remember a equals x over y equals 5 over 2, and that one is straightforward. Therefore, x, the ratio of x to y is 5 to 2, all right? And again, you can cross multiply if you wanted, but hopefully that's fairly clear. Right, so that's the whole paper done. I've tried to go through it as quickly as possible to reduce the time. If you have any questions, any suggestions, or any topics that you'd like me to expand on, as always, you're very welcome to leave it in the comments. And I'd be grateful if you subscribe and watch out for other videos and future papers that I'm doing. And if you're studying for exams, best of luck. All right. Thank you for watching.